is what is petting, port address translation, and many other things also, right? So last classes, guys, we was go very deep inside the networking world about networking, and the concept what I explained, it is generic concept apply on any different kind of tools or the platform. Because we are learning Docker, so I relate those concepts with respect to Docker. So I show you some of the Docker command or Docker network command, okay, to relate those concepts in the Docker. So today, guys, plan would be till date we have used a Docker network that is pre-created network, okay. But today we will create our own custom network. That is one of the topic what we are going to deal with and what we are going to perform today. So we're going to go more deep into Docker network and going to create our own custom network in the world of Docker. That is one of the plan. And then after I create a custom network, in this custom network, we are going to launch one project. So today, guys, you'll see we will also create one entire project that's called multi-container project or multi-container app. We are going to deploy. Okay. And when while I'm deploying the multi-container app project on the top of Docker platform, okay, you will see there will be many new concepts or small concept to be covered in the today's class, right? So there's a high level agenda for the today's class. So before this, let me very quickly jump to the machines running locally. We just need Docker. You can run the Docker in the cloud. You can run the Docker system like in Windows or any Mac OS, or you can run the Docker in the virtual machine. In my case, right now it is running the Docker machine or virtual machine, I can say. Okay. So one minute, guys. So this is the machine I am using at this point in time. 1 minute. Yeah. So the machine, and I just want to quickly check it is running with Docker or not. So we can use Docker info command. If this command is running, it means Docker is installed. And if this command is giving you some output, that is called Docker server. Talking about, I am running with Docker this particular version. Okay. And plus, they're also talking about how many images I have downloaded and in my local repository, how much container we have, how much running and stopped. So all the things we have here. But same time, because I'm also known as Docker engine. So they tell you that this Docker services has some plugin respect to network. Network. Okay. And plugin means what kind of network capabilities Docker support. Okay. And or you can say in this other word, what networking Docker has. So we have bridge driver, host driver, and null driver. We have some other use cases, overlay network, IP, VLAN, or Mac VLAN. That's also they support. So what are these? Maybe in upcoming classes we'll talk about it. Okay. At this point in time, this Docker is supporting these driver, and because they're supporting these driver, so if you want to create your own custom network, so at that point in time you can decide which driver you would like to use. And the difference on the driver I explained, guys, in my last classes, right? So example, if you want to create a network, something like this. So what is network? One area. In this area, right? Whenever you create a network, behind the scene, they create a bridge, okay? And this bridge they will create is called L3 bridge, means layer 3 bridge of your OSIM model. That's called network layer. And 3 bridge is means this is a kind of software work like a router, at the same time they work like a switch. So any device or any program that work like a router or work like a switch same time as a combo box is called L3 switch or all L3 bridge. So if you want to create a bridge so that any machines running in your lab or in your network, if they want to connect to each other, so they will connect via this switch. Or same machines, or obviously in the Docker world, the machine is called container. So if these container, if they want to go out to the internet, also when I say internet, I also mean to say anything that is running outside this network, in the outside network. So these container, if they're running with the IP addresses network range, let's say it's 10.0.1 is my network name. That means my network name is this one and my net mask is this one. Okay. So if you're running with this subnet mask or this range, okay, where the first IP is network name, second IP I can give to my router, because router also have IP of inside your private IP. So let's say first IP I would like to give to my router, and the remaining IP I can give to my container. So everyone has this network range IP2. This guy has this network range, same network range IP2, 3, and 4, and so on. Okay, so I'm running with my LAN. So in the world of Docker, it is known as your network. Okay. And in this network, we are running multiple container. And if you want those container can ping to each other. So there should be kind of one switch and also have IP address. But at the same time, I want they will go outside also. So we need router. But here, guys, they have a router with SNet enabled that I explained to you. And they got SNet, they can go outside other area or they can also go to internet. Okay. But this router also support DNetting. If anyone from outside, if they want to come in, then we can use DNetting. And obviously we connect with the port, so DNetting is special case called petting. So all the concept I very detailed, slowly step by step in my last classes. Okay. But if you want this kind of network where you have S3 bridge, S3 bridge is the one who can give you S netting and D netting. That means the bridge is, then you need a driver that's called bridge driver. The first point is your Docker engine. Are they supporting bridge driver? Yes, because they're supporting bridge driver so that we can create a network network that has a driver called bridge. Right now we already have one network. By chance the name is same, you can give it the name also. They're using the bridge driver. That's what we're using till date. But if you want to create your own custom network, okay, you can also create. That's what the plan. Network, you have to tell which driver you would like to use: bridge driver, host driver, overlay driver, null driver. Everyone has a different use case in the world of network connectivity. Okay, so plan for today is I want to create a network. Okay, my own custom network. And why? A lot of reasons, because one of the network this is given by this guy. It's also known as default network. They given some pre-created IP address range. Okay, so we see write the name here. Here it give the name, not the driver name. Name. So here they give you a network with pre-enable masquerading enable, that's called S netting. They give you pre network range, the router and IP address, and many more things. But if you have a requirement, you want to create something very custom, your own network range, own gateway name, other different settings, whatever the thing is. Okay, so there okay, many settings we can do. So if you want to create a network with your own custom settings, that was the use of custom network. Okay, so that's what the plan is. So how to create the custom network? Let's say my plan is to create a network with this network range or subnet mask, what I say the same thing. How you can do so? So for this, we have a command called Docker network. And if you guys see the help of Docker network, hit enter. They say you want to create a network, list, inspect, or create. Okay. So you can use a create command, right? I can say I want to create a network. Again, I don't know the further options. I can see the help with have an H. And in the network, guys, we can do a lot of settings. Okay. So what are the possible settings, whatever we have, okay, we can apply here. One of the very common setting would be I can tell my subnet name. So what is my subnet name? This is called network range or network segment, also known as CIDR. Okay. So according to my plan, I want to give this CIDR. Okay. 10.1.0/255.255.0. That's all. So this is one of the options we can give. Okay, next option would be allocate the IP address to the container. And if you know, understand from my last class, when I write this, that means your network octet is 3 octet. This is net mask. So this will be your network uh, name to be reserved. That means the first allowed IP address in the network is 0.0, then 1.23 till 255. But after these total 256 IP addresses, if you think some of the IP address you want to reserve and provide to the container, that's also we can do. Okay. So let's say IP range. But we come from this network range, let's say from IP 10 to IP 20. So any container, whatever you launch, they will have this network range. And I told you guys in my last class, what a network range, your network route also created this network range, but IP that will be given to the router, to the container would be from this number. So from 10 to 20 means total 11 IP address we reserve for container. It means kind of 11 container launch with the okay, that's what we give. Then the most important thing is driver. Which driver you want to use? You want to use host driver, null driver, bridge driver. So I would like to use bridge driver. And if you don't write this keyword, then by default they take bridge driver only. Okay. Otherwise, otherwise you can set up a lot of configurations here. So what are configuration? These things what I explained to you. Options. So these things also set up. Do you want to enable masquerading? You want to enable, if you know about MTU or many other settings, you can do here. And those setting options, whatever they support, you can see the document of the Docker. They give you all the options, whatever they supported with respect to network. Okay. You can write here with the config and config only keyword. Okay. Anything else right now as such, we don't need to do anything. These are the some of the important keyword we can write. If you think you want to create an isolated network that can't go to internet, I told you as soon as you use bridge driver, they will do SNET enable, means your content can go out of the internet. Internet. But if you want to disable the internet connectivity, none of content can go out of this lab or the network, then you can use internal keyword. So they restrict the access to the network, outside network, external network. And so these kind of customization we can do. So I know this much information is enough. And according to the Docker create command, there's a syntax. We have to give all the options. Some of the options we given here, and then you have to give the network name. So let me give the network names. Let's say Linux World Network. It's just a name, you can give any name. Okay, that will be created. One more thing I hear, they say this syntax does not support. They say it supports CIDR format. It means instead of 255, we write /24. It's got prefix length or CIDR syntax. Okay, and they say no matching subnet for this range. Okay, so for this we use slash and it should support one minute. The range would be, so we can go and check the document of the Docker, what syntax they support, maybe hyphen, because this is a range. I think range is right. I don't see any challenge in this no magic summary range. It should be same or maybe 10 to 20. Okay, some range syntax they support very quickly. Just check the Docker document. Rather than we memorize this, we can very quickly see the syntax of IP range, what syntax they support. Okay, it is not compulsory also. By chance, again, this it look like they support this. If you can understand the concept subnetting concept, that's what I believe some document is talking about. They support. So range syntax they doesn't. Otherwise, you can go to this document. They might also tell you what kind of syntax the range supports. Some example they might give you. Might give you. So again, they support the syntax. Okay. So what I'm going to do, again, I don't want to go for networking part in more detail, but if you want to allocate, let's say the IP address 10.0.1. Let's say 4 till 8. Okay. So 4, 5, 6, 7, let's say till 7. 4 IP address if you want to provide to the container, then we mostly write 10.0.1.4/30. Now, from where this number come from? For this, you have to learn a lot of thing about subnetting concept in the world of networking, but it's come from the networking concept. Okay, a very simple formula. The total bit IP address is 32, and if I give the /30 as my subnet mask, then only 2 bit left. 2 bit means 2 to power 2. That means a 4 IP address. That's for the 4 IP address. And first IP address is this one, so we normally write start first. This is a very quick formula, but otherwise, if you go more deep into just learning networking, then you come to know this concept. Okay, so if you want to give allocate 4 IP address, you can do in this way. So let's do for this. Go for this. Or let me have more IP address. So let's say I would like to allocate from 0.0.1.4 till 28. Means 32 minus 28 is 30 by 28 is 4. Make 4 means 16 IP address we are going to allocate as a range. So nothing much, but the very quick formula is given to you. Okay. So that's what I can give here. So here range we have to write in this way format. 10.1 point, let's say 0.4 slash 28. Okay. Should be, let me start from 0, that's okay. Because some initial range they say they start from 0, means till 0 till 15, 0 to 15 IP address we are going to allocate. So now, so this is the final command we ran over here. You see Docker network list. Same driver we are using, but my network name is this one. Okay, my network name. And if you try to quickly inspect this network name, now you can see this is what created automatic. So based upon your setting, you're using this driver with this name, just a name, and this is what they have created. So this is my total network name, and this is my IP range. So any container, whatever we launch, they will launch with this range. Now, how to create a network? How to launch the pod? That's called container technically. So you guys know the command docker run dit. Let's say I want to use a Ubuntu container with 14.04. If you does not write anything, so by default they use this network name. But if you want to launch in this lab or this network, then there's a keyword called network. And then you can give your own network name, whichever network you want to use. That's all. This time now your container is running, but the launch in this network, and because they launch in this network, so the entire network settings come from this network given to the container. So I can say docker inspect to this container ID. And one more thing, guys, for the ID, all the ID, you can initially give 4 character also. So all the unique character, whatever you have, if you give, then they will treat the same container. That's also we can give a syntax here. Okay, I can see this water here come up, right? Okay, so the first IP, that is what I was talking about. Go to container. The actual first IP is for network. Second IP, mostly there is a for the gateway IP address, and remaining IP address they give to container. Okay, so that's what we can see here. Okay, and second thing, they belong to this network. That's what you can see. Okay, and even though we can see in one more way, if you go to inspect command of the network, you can see now in this network, we are running one container with this IP address. That's also you can see. And let me launch one more container in the same network. And let me give the container name. Let's say name is Linux World OS 1. It is just a container name. Container name. And if you inspect this container, you see 2 container running in the same network. Say IP 1.1, 0.2 belong to same network, and this network we designed, we created. That's what we can see. And very quickly, if you inspect the container, Linux World OS 1, whatever container name we given, you can see this also. Okay. Now, one more thing I want to tell you guys. If you go inside this container, how to go? We can use a test command, for example. Okay, let me go inside this container, F32E. So I'm into this container. You can see from ID also this container. And if you're in the IF config command, you can see network card, same thing gonna come up. And last IP of your network range is 250, is a broadcast IP. But yeah, they come from the same network. And one more thing, if you see the routing table, so routing table guys also see the same network, right? So this is what my network name come in the routing table. All the remaining IP will go to my gateway. It means if I try to ping any other IP, does not belong to this. So they always go to this one, any IP. They go to gateway. And gateway is bridge gateway. So they do S netting and they connect to the outside world. So connectivity is working fantastically fine. Okay. But from this container, if you want to go into other container, other container, let's say 3, it is also pinging. So technically, I have created the actual working network. Every container can ping to other container can go to outside world. So it's working fantastically fine, guys. The network what we created has no. One interesting thing I want to tell you here is, if you try to ping to this IP, it's working. But if you try to ping with the name of the container, that is also working. So this is the beautiful thing. Okay, this is a beautiful thing. Okay. So my point is, whenever you create a custom network give you a facility that one container can ping to other container with the container name. Okay, that is interesting thing. Okay, it means, let me go out from here. It means if this container want to ping to this container, if they does not know the IP address, this container can ping to this container with the help of ID of the container or with the help of name also. It is beautiful because container is one thing. Okay, let's say this is a container. I'm going to remove this container OS1, forcefully removing because running behind the scene. This container remove. Okay, and I want to launch one more container. Okay, so one more container in the same network. So you know what happened, guys? In this container, we are running with database, for example. I deleted the container, I launched one more, and here I'm running my front end, back end that connect to my database. Okay, and I told you in my last class, when the container launched, your database automatically started. But my front end or back end, if they want to connect to a database, the minimum requirement is we need to know the IP address. But every time when the content deleted and new content launched, there are higher chances next time IP will be different. Different. So if the IP change, then I have to go to my developer who write a backend code in Python, Flask or Java, and tell this guy now IP has been changed. So they will go to the code and update the new IP address. Okay. So technically, every time your container delete and new content launch is launching, means deleting. Automated there. So why is not automated? Because I want to test my application running with database, running with backend, front end. After I delete, again I create for testing, IP change, I have to go to code. And after I go to code, guys, 1 minute, my voice is breaking. Some guys. For me, my voice. Asking a developer to update your code again and again, it will look like a manual concept. It slow down the thing. and also having a chance a lot of mistakes. Okay, so what we can do, okay, what we can do, I can launch a container in such a way the IP is the one that keep on changing, ID is the one that keep on changing, but name is one thing that would never change, because this is what we are giving her as a hard coded, right? Hard coded. So in the command we get the name. So next time your IP of this new container can change, ID of this new container can change, but this name of the container is not changed. That means now from this container, this one F3 to E, like you want to connect to this container. Now you don't need to know the ID, neither IP address. You only need to know the name that is always fixed. It's connected. It's pingable, right? So I can do one thing. I can tell my developer that your database or the other application wherever you want to connect would be reside at this name. Okay, so that makes sense, right? So what IP next time gonna come up does not matter. Name is always same because we are giving hard code name to my container. That is one of the good reason why we should give the name of the container. Because if you don't give the name by yourself, then name also been changed all the time when you launch next time. If you give the hard code name while launching the container, the name is fixed. So in this cases, you can connect your one other container with the help of name. Okay, this is one thing. And second thing, guys, normally when you talk about name is mostly host name. Okay, but here name with your network name is actually full name. Yeah, same thing. Okay, is a full name. It's called fully qualified domain name. Okay, so if you are within the same network, then they will add, or maybe they have other things also. Let me skip this part for a minute. But the point is, either you can use your content name or your content using running in this network. Okay, so in this network name you can also give, because we can have multiple network also. Okay, so this will tell this container is one of the container name belong to this network. So this is equals to this. This is normally known as host name. This is known as FQDN, fully qualified. One thing. Second thing, you guys know, in the world of computer only ping connect with the IP addresses. They don't understand the name as such. Okay, so what happened, guys? Here, your first name is converted into IP address. Okay, so for this, any name that convert to IP address, we need a DNS server, domain name system, domain name system services we need. Okay, and that is a beautiful thing you will see here. Whenever you create a network as a custom network, okay, so custom network give you a capability capability to create a DNS server. It is not visible here in the inspect command, but your custom network give you a capability to create a custom DNS server for the network. So that is the reason when you do inspect in your OS, let me do inspect on your container, Linux OS1, what are the name you give, you can see this setting gonna come up, right? So the setting, if you till date what a container launch, you will never see these settings. But here in this OS or container, I launch in my custom network, and custom network give a capability. Okay, they automatically set up the DNS name for you, and they say what are the ID of this container, and the name of the container is pingable. Anyone want to ping with any of the name, they can ping. They don't need to memorize the IP address. IP address, then we ping with the IP address. That will be done automatically automatically buy the Docker for you. Okay. And one more thing I want to show you, if I go inside this container, okay, inside this container, there's one file, guys, in the Linux. It's called, it is a host file, it's a Linux file. Okay. Here, guys, they maintain this information. So whatever your container ID is that is equals to your container name or the OS host name, and what are the IP of the host name, they update here into this one. So the container know their own IP address, and if you want to ping the container with the own host name, they can ping. Is pingable. This is by default nature, actually, nothing new. But the thing what I'm trying to tell you, it is not by default allow. If you create a custom network, then only this configuring your custom uh, the world of Docker network here, they will create for you. It means your custom network give you two facility. One, they work as a DSCP server, and they work as a DNS server. So any network that work as a DSCP server or the DNS server, this is what they're doing. Okay, that is technically known as IPAM. So anyone who that is IPAM, that means they support DNS also, and they have a DNS or DSCP support also. That's the meaning of IPAM. So custom network give you actually true IPAM capability. Okay, capability. But let me first delete my container. Let me have a new containers. Okay. But if you launch the same container in your default network, the way you're done till date. So if you launch a container in the default network, that's called bridge. If you remove, they will launch in a default network. Let me launch one container with this name and one container with this name. Both the container launch in the default network. How I know? I can inspect my container. Okay. So this is a default network we have. And here we have IPM configure null. They will take the IP for DSCP, but DNS name is null. That means from one of the container, let's say LWOS1, if you try to ping to other OS with the IP address, it works. But if you try to ping with other OS with the name, it is unknown, because there's no one to convert IP into name into IP address, because there is no DNS. So default network has some extra capability you can achieve. Okay, but one more interesting thing I want to tell you about the default network. Okay, that is, if you think, if you have a requirement, okay, that I am going to launch uh, the container with this name, and I also want to create one more container with the other name, but I want first container can able to ping to my second container with the name with the name. Okay, so we can do this thing in default network also, because default network does not support DNS as such by default. We can do some settings for extra setting, there's different point, but by default it does not support DNS. It means this container, if they want to ping to this container, they should know the IP address. But I told you guys, IP address keep on changing. Okay, so sometime if IP change and you're running two app, multi-tier app, so they don't have a connectivity if IP change. So I want to use a name for the connectivity as a DNS name. But the default network is the bridge network that does not support by default the DNS name. But in the default network, this is a bridge network. If you want to achieve the same capability, what I was trying to tell you, that they can ping to each other or connect to each other with a name, then there's a specific keyword for this called link keyword. Link keyword. Like I said, this container, now I'm going to link with this container. Okay, that's all. Now what you will see is like a normal container. You inspect this container, oh, as one, still you can see DNS is is null. If you inspect this container, still you see DNS is null. Okay, but if you go inside this container, OS2, and now if you try to ping to OS1, you can see it's pingable right now. This is working. So without DNS also, it is working. Okay, so by chance XYZ region, he does not want to create any custom network and you want to launch a container that mostly we see in the default network of the Docker. But if you want to, one container can ping to other container with the name, because IPs keep on changing. Okay, I don't want to lose my connectivity if the container recreate or re-terminate and create. Then we want to use a name. Your name is always fixed. Then you can use link keyword. But there's no DNS, then how it's working? So those who know little about Linux, if in the networking world, if you want to connect one container other container with the name, right choice is always DNS. But if DNS is not there, then there's one local file called etc host file. This is what the guys they use. So when you link, so what they do, they come to this file and they update the entry that this OS where you're going to ping, we know the IP address. We know the IP address. That's what they update here. So technically, guys, whenever you want to use any name in ping or curl command, they always go to this file. If they know the database, what is the IP of this name, they convert and then they ping. So this is the local kind of local DNS approach they use when you use a link keyword. But if you go to container one, okay, and from the container one, if you try to ping to container two, it is not work. So reverse does not work in this example because they don't have a reverse entry. So technically, if I show you the history, I launch a first container, but I want second container will connect to a first container container with the name, okay, in one direction. Then the second container I can link to first container, and there's a lot of use case for this. The use case that I was talking about in my last classes, guys. Whenever you have any multi-app container deployment where you're running with a database, okay, and on the front of database we have your backend. Okay, so understand one thing, guys. Let's say this IP is one, this IP is two. Backend is the one who always connect to database. Okay, database never come to your backend and connect. This won't work, right? We always want when the client hit, my backend will go and connect to database. For this, either you can use the IP of the database or you can use the name of the database. So in this case, I will first create a database, give a name. In my case, let's say I'm give the name Linux OS1. Then I launch my backend and I say backend what a name would be, but I'm linking you with this name. So you can use ping command or you can use just the host name for the for the connectivity. Okay, so that is the case we can use the world of default network because they don't have a proper SSDNS support. But in this case, if your first container, okay, deleted, deleted, okay, uh, let's say Docker remove LWOS1. So this having IP2 is been free. And now if you launch some other container, other container let's say some a random name. So that container will take the IP2. Then if you launch the first container again, let's say database, again you launch after some time, the same name, this IP may be something else, the IPs keep on changing. So technically, initially the IP of this container was 2, but we deleted, we launch something else in between, then we launch again. So in this case, if you see Docker inspect command, what IP over 1 has been something else 4. But initially we link this name to this container. Now, if you go to the container that is working, let's say the backend, and kind to do the database of this name. Okay. Now, if you go to this file, so still, guys, they are linking to 2. This file does not update. It means you try to ping to OS1. It look like you're pinging to this name, but the ping to 2. But now in this case, now a 2 IP belong to this guy, not this guy. This is just some extra container we launch for other purpose. But my intention is to create to this container, but IP changed, but this IP is not updated. So it's like a misleading. They're pinging to 2. Okay. So my point is linking is not a good and great concept. I've seen some of the guys use linking, but this kind of challenge you will face the world of linking. So we always want to use a DNS. The DNS guys, they delete, they create new IP gonna come up, new name gonna come up. They will update everything. You don't have to worry about any time. So connectivity in the world of name. That's what I like to tell you. Okay. So it's good practice. Let me delete first. It is good practice to have your custom network. Okay, so you can define your network the way you want to define. Plus, they give you some extra capability. One of the capabilities is DNS by default support. So everyone can ping to each other without knowing the IP address. The IPs keep on changing, so we don't need to know the name. Just use the container name for connectivity. So that is a reason, guys. There's a good practice. The good practice is whenever you launch a container based on the use case, okay, give a container right name.